All right, so I think that's recording. We're taking a look at the review problems from Skill Packet 7, and many of the problems that we've been dealing with so far have been the idea of coterminal angles. Angles that, when written in standard position, have the same initial side and same terminal side, with that initial side always coinciding with the positive x-axis. So um, when you're working with radian measure, it's probably a little bit less familiar to you than working with degree measure, because we've all um, talked about even from before your geometry days of 180 degree or a 360 degree dunk or whatever. I think that most people are just familiar through everyday usage of degrees, but definitely not so with radian measure. So I want my answer, I want to find an angle, I'm going to call it theta, and I want this theta to be between 0 and 2 pi. But 2 pi is not very written conveniently to compare it with this fraction. So I want to rewrite 2 pi as 6 pi over 3, and my final answer will be between 0 and 6 pi over 3. So I don't want to sit here all day and subtract 6 pi over 3 from this. How many times will 6 go into 58? Well, probably 9 times, right? If I have 58 pi over 3 and I subtract 9 complete revolutions, then isn't that going to be 4 pi over 3? If I Yeah, okay. So there's my answer, because this 58 pi over 3 um, is gonna rotate around, 9 times, then plus 4 pi over 3, and this angle of 4 pi over 3 written in standard position has the initial side the positive x-axis, the terminal side over here in quadrant 3, and if you were to graph out 58 pi over 3, you've got all of these complete revolutions, but it's going to start here with the positive x-axis and end on that same ray right there. So 4 pi over 3 is my final answer, and I hope that helps. And let's see, is the next one? All right, I'll do the next one in another video.